Hello students, welcome to my YouTube channel. In this video lecture, we are going to look at new questions of Great Circles chapter in 𝐃𝐞𝐻 Gen Math. So far we have solved 30 questions. In this video lecture, we are going to solve the next 10 questions, 31 to 40. Let's start with question number 31. The angle between the true Great Circle track and the true rhumb line track joining points alpha and Bravo at the place of departure alpha is what? So the angle between great circle track and rhumb line track, this angle the is called the conversion angle. Okay, so that means we have been told or asked to find the conversion angle. So both are located at same latitude, and one is in the western hemisphere and another is in the eastern hemisphere. So convergency. So let's plot this first. Let's say this is your Earth. Okay. Now both these places are very close to the anti-meridian of prime meridian. 165 west, 177 east means these both positions are close to the anti-meridian, international date line. So what I will do is I will draw a prime meridian here, 0 degree, and the reciprocal of which is 180 degree meridian I will draw here. So 180 east is this side, west will be that side. Now position A is in the western hemisphere, 165 west. 165 west, and position Bravo, correction, is in the eastern hemisphere, 177 east. Okay, so these are the two positions. Now both are in the south hemisphere. Both are in the south hemisphere, that means the south of the equator. Okay, so these are the two positions across the anti-meridian. So I will draw these two positions here. So since it's south hemisphere, great circle joining them will pass through the nearest south pole. So A is here, B is here. Fine. Now convergency. What is convergency? Convergency is D long in terms of degrees into sine of latitude. So difference between two longitudes here is 165 west. So the difference between them, this difference between 180 east anti-meridian and 177 east is, this difference is equal to 3 degree, and this difference 165 minus 180 is 15 degree. So total D long between positions A and B is equal to 15 plus 3, that is 18 degrees, into sine of latitude. Both are located on the same latitude, so sine 60. So now 18 into sine 60 is equal to 15 degree 35 minutes. 15 degree 35 minutes. Conversion angle will be half of convergency. So half of convergency means half of 15 degree 35 minutes. That is equal to 7 degree 47 minutes. Okay, or approximately 8 degree. That means the conversion angle between this rhumb line track and this great circle track is equal to 8 degrees. 8 degrees. So select that option which is closest to this value, 7 degree 47 minutes, 8 degree. Next, which of the following is true of all parallels of latitude? Okay, so all parallels of latitude, meaning all latitudes including the equatorial latitude. Now remember, let's say this is your Earth's surface. Okay, so all parallels of latitude will run in east and west, will run east-west direction, right? They will run east and west direction. East is here, west is here, north is here, south is here. Now the equatorial latitude, the main equatorial latitude, 0 degree equatorial latitude, is the only parallel of latitude which is both a great circle and a rhumb line. Okay, all other latitudes apart from the equator are rhumb lines only. Okay, are rhumb lines only. Okay, are rhumb lines only because rhumb lines are lines of constant direction. So all latitudes have one constant direction. They run either easterly direction or in the direction of west. Same equator, east and west direction. Along with that, the equatorial latitude is also a great circle because the center of that equator is the same as that of the center of the is the same as that of the Earth. Okay, so that's why equator is a great circle as well. So here they have asked us which of the following is true of all parallels of latitude. That means what is that quality which binds all parallels of latitude together. So they are neither rhumb lines nor great circles. They are rhumb lines but not great circles. They are both rhumb lines and great circles. They are great circles but not rhumb lines. So the correct answer is all parallels of latitude are rhumb lines but not great circles. Right? Equator is the only great circle. So bravo. Next, aircraft departs from a particular position along the meridian for 2950 miles. Okay, so the position of aircraft is 4 degree 10 minutes south, 178 degree 22 minutes west. So on this particular longitude, 178 degree 22 minutes west, aircraft flies for 2950 nautical miles northwards. Northwards for 2950 nautical miles. From there, after reaching its destination, it changes its course of direction. It flies westward along the new parallel of latitude for 382 miles. So what is the final position? So let's draw this. So this is your Earth's surface. This is your equator. 4 degree 10 minutes south and longitude is 178 degree 22 minutes. Okay, now we are going to fly northerly direction. That means we are flying along the same meridian of longitude 178 degree 22 minutes west in the northwards direction. What will happen is we will be changing our latitudes. 4 degrees south, 3 degrees south, 2 degrees south, 1 equator, then fly in the northern hemisphere, right? So we are going to actually follow a great circle track, and hence we will calculate great circle distance, difference in latitude multiplied by 60. So the distance great circle is 2950 d lat into 60. So d lat in degrees equals to 2950 by 60, which is equal to 49 degree 10 minutes. 49 degree 10 minutes. Now this is the total difference between the initial latitude and your final latitude. Now the difference between the initial latitude and the equatorial latitude is how much? It is equal to 4 degree 10 minutes. Right? Our total difference is 49 degree 10 minutes. So 49 degree 10 minutes will be divided into two parts. 4 degree 10 minutes in the south hemisphere and the remaining 45 degree 0 minutes in the northern hemisphere. So this remaining 45 degree in the northern hemisphere. So your final destination or final point will be somewhere here where the latitude is 45 degree north. 45 degree north. Okay. Now from this particular position at this latitude 45 north, 178 degree 22 minutes west, you fly westwards direction for a distance of 382 nautical miles. So when you fly westwards direction, you will be actually flying along a parallel of latitude, a fixed parallel of latitude which is 45 degree north. So when you fly along a parallel of latitude, you are flying a Ramline chart. So Ramline distance equals to d long in minutes into cos lat. So 382 miles equals to d long in minutes into cos of 45. So d long in minutes equals to 382 divided by cos 45, that is equal to 540 minutes. 540 minutes. 540 minutes divided by 60 is equal to 9 degree. That means you are going to change your longitudes by a difference of 9 degrees. So your initial longitude is 178 degree 22 minutes west. Your final longitude will be different from this initial longitude by a value of 9 degree in westerly direction, towards westerly direction. So let's draw this. Now the diagram for rumblines is something like this. You are going to draw the diagram of the earth with respect to the north pole, as if you are looking at it from above the north pole. This is your prime meridian. This is your anti-meridian east and west, 90 east and 90 west. So 178 degree 22 minutes west, 22 minutes west. Now you are flying in the westerly direction. That means you are flying clockwise direction. Okay, westerly directions are clockwise. Now 9 degree west is the change in d long. So 178 degree and 9 degree. Now what is the difference between 180 degree west and 178 degree 22 minutes west? 180 degree minus 178 degree 22 minutes equals to 1 degree 38 minutes. Right? Total d long is 9 degree. Out of that 9 degree, 1 degree 38 minutes will be travelled in the western hemisphere. So what is the remaining d long? Minus 9 degree. Remaining d long is 7 degree 22 minutes. So this 7 degree 22 minutes will be travelled in the eastern hemisphere. So position, a final position will be 180 degree minus 7 degree 22 minutes. That is equal to 172 degree 38 minutes east. Okay, so our final destination Bravo is what latitude? Latitude 45 north and 172 degree 38 minutes east. Correct? Next. A rhumb line is what? Is it a line convex? Convex means bending towards something. Towards the nearest pole on a Mercator chart, a line on the surface of the earth cutting all meridians at the same angle, the shortest distance between 2 points on a polyconic projection, any straight line on a Lambert's projection. So a rhumb line by definition is a line on the surface of the earth cutting all meridians at same angle. Okay, next. Alpha is 55 degree north, Bravo is 54 degree north, 10 degree east. Average true course of the great circle is 100. The true course of the rhumb line at point A is what? Let's see. Let's consider this. This is your earth. This is the prime meridian 0 degree. This is your equator. Okay. So 55 degree north is here. Let's say 55. 54 degree north, 10 degree east will be here. 54 degree north, 10 degree east. Okay, so now the rhumb line joining them will be like this, and the great circle track will be this. Now they are talking about average great circle track. Okay, average great circle track. So see, this is your great circle, let's say, between points alpha and bravo. Now the line of direction, the direction of this rhumb line track will remain constant as you go from point A to point B, 0, 9 or 0. But the direction of great circle track will continuously change as you progress from A and go towards B, right? The direction of the great circle track will constantly change. Now the average of this great circle track, average of great circle track at A and great circle track at B will be somewhere here, right in the middle, over here. That will be the average of the two great circle tracks. Now this average is parallel to this rhumb line track. So at this particular point on the top of the great circle track, the direction of the great circle will be equal to your rhumb line track. Okay, so if the average great circle is 100, what is the true course or direction of the rhumb line track? The direction of the rhumb line track will also be equal to 100 because both are a parallel at that points. Okay, so the great circle here will be equal to your rhumb line direction here. Next, aircraft passes position A 60 north 120 west towards position B, which is located on the same latitude 140 degree 30 minutes west. What is the great circle track at the point of origin? Okay, at departure. So this is your Earth. Okay, this is your prime meridian. The first position is 60 north 120 west. 60 north 120 west. The second position is 60 north 140 degree 30 minutes west. Okay, now both are in the north hemisphere. So the great circle track will be like this, passing to the nearest north pole. So this is your rhumb line track, this is your great circle. Now we have to calculate the direction of great circle at point A to B. Now see, the direction of rhumb line track at point A is what? It is 270. Rhumb line track at A is 270, right? We are going directly towards west direction, in west direction. Great circle track at A will be rhumb line track at A plus convergency angle. What is this convergency angle? Convergency angle is this part, this small part, the angle between great circle and rhumb line. So what is convergency? Convergency is B long into sine of latitude. So the B long 120 west or 140 degree 30 minutes west. The difference is 20 degree 30 minutes into sine of 60. So sine 60 into 20 degree 30 minutes is 17 degree 45 minutes. So convergency angle will be half of that. So divide by 2 is 8 degree 52 minutes or approximately 9 degree. So great circle track at A will be rhumb line track at A 270, convergency angle 9 degree. So 279er degree. This is your great circle track at A. Okay. Next. Parallels of latitude except the equator are rhumb lines, are great circles, both rhumb lines and great circles, neither rhumb lines nor great circles. So they are rhumb lines. Next. A is 48 degree 50 minutes north and B, correction, 48 degree 50 minutes north, 2 degree 16.5 minutes east. What is the antipodal point? So let's say this is your Earth surface. Okay. So we have one position is given, let's say 50° north and 100° east. So the antipodal point is the direct opposite point, is the point directly opposite to this position. So the antipodal point will be 50 degrees south, 50 north will become 50 south, and longitude is 100 east. So that this longitude, this new longitude will be 180 minus 100, that is 80°. So 80° 080 west. 080 west. Make sure the sum of the longitudes is equal to 180. So if this is 100, this has to be 80°. Only then the sum of them will be equal to 180. So now here the latitude is 48° 50 minutes north. So the opposite latitude will be 48° 50 minutes south. Longitude is 2° 16.5 minutes east. So the opposite longitude will be 180° minus 2° 16 minutes 16.5 minutes. So that is equal to 177° 43 minutes west. East will become west. And now the sum total of 177° 43 minutes and 2° 16.5 minutes is equal to 180°. Next, on a Lambert's chart, great circles that are not meridians are what? So they are curves concave to the pole of projection, straight lines within the standard parallels, curves concave to the parallel of origin, straight lines regardless of distance. So they are curves concave. Concave means bending away from something, from the parallel of origin. So let's say this is your Lambert's chart. This is your standard parallel number 1, standard parallel number 2, and this is your parallel of origin. Okay. So the great circle track will be a track bending away from this parallel of origin, like this. In the north hemisphere. The south hemisphere, it will be bent away from the parallel of origin towards the south pole. Okay. So this is your great circle track. Next. The pole of projection in case of Lambert's chart will be on the top. Will be on the top. So it will bend towards the pole of projection, or we can say it is bending, or it bends away from the parallel of origin. 40. In a direct Mercator chart, a rhumb line appears as a curve convex to the equator, means bending towards the equator, curve concave towards the nearest pole, away from the nearest pole, straight line complex curves concave to the equator. So in a direct Mercator chart, rhumb lines appear as straight lines. Okay, that's it. So this concludes our lecture. I hope you have understood all the 10 questions I have done in this video lecture. Practice them, read the theory, watch other lectures on great circles, rhumb lines, convergence that I have solved, that I have made and uploaded to my channel. Best of luck.